So what if you could build your very own team of AI researchers? I'm talking about a dedicated crew that could grab a tiny spark of an idea, run all the experiments, crunch the numbers, and then write a whole academic paper on it. Sounds like science fiction, right? Well, it's actually the powerful idea behind a new framework called freephdlabor, and honestly, it might just change how we think about scientific discovery. So let's dive in and see how this thing actually works.
All right, so here's our game plan. First, we're going to tackle the big challenge. Why is automating science so darn hard in the first place? Then we'll get into the free PhD lab framework itself. After that, you'll get to meet the whole AI research group agent by agent. We'll even watch them go on a mission from a simple idea all the way to a finished paper. And finally, we'll zoom out and think about what this all means for the future of co-scientists.
Okay, let's get right into it. The challenge of automating science. You know, on the surface, it sounds like something we should have figured out by now, but building a true AI scientist, one that can actually discover something new, well, it turns out that's a whole lot harder than it looks.
And that really gets to the heart of the matter. I mean, can a team of AI agents really automate scientific discovery? We're not just talking about automating one boring, repetitive task here. No, we're talking about automating the entire process, the whole winding, messy, unpredictable journey of discovery. It's a huge, ambitious goal for sure.
So, the big difference really boils down to this. Most of the older systems, they're built on these super rigid, pre-programmed workflows. You know, it's like do step A, then do step B, then do step C. But that's not how science actually works, right? What happens if you get a totally unexpected result at step B? A rigid system just breaks. It can't adapt. And that's exactly where freephdlabor comes in. It's built for a dynamic workflow. The plan literally emerges in real time based on what the agents are finding. They can think, they can pivot, they can adapt, which, you know, is what real research is all about.
And this leads to another massive problem, one the paper calls the game of telephone effect. You remember that game from when you were a kid, right? One person whispers a message, and by the time it gets to the end of the line, it's complete nonsense. Well, the same thing happens with AI agents. When they just pass text messages back and forth, details get lost, they get distorted. A super precise measurement might turn into a vague guess, and in science, that's a total deal breaker. You just can't have that kind of error.
Okay, so how does freephdlabor get around these huge problems? This is where we get into the framework itself. Think of it as the blueprint for their autonomous research team, designed specifically to beat that rigidity and the whole game of telephone thing.
All right, here's the first masterstroke, the architecture. Instead of having agents talk to each other in a messy, chaotic line, freephdlabor uses what's called a star-shaped architecture. Right in the middle, you've got the ManagerAgent. This guy is basically the boss, the principal investigator of the whole lab. It coordinates everything, keeps track of the big picture, and hands out jobs to the other agents. This central command is the real secret sauce that makes the whole thing so dynamic.
And the second masterstroke? This one directly solves that whole game of telephone disaster. Instead of passing around these long, messy text messages that can get garbled, the agents communicate using a shared workspace. It's so simple but so smart. They just save their work, code, data, charts, whatever, into a folder and tell the other agents, hey, the file you need is right here. This means communication is basically perfect. No information gets lost. You're always working with the original, pristine data.
Okay, so we've got the architecture down. Now it's time to meet the actual AI research group. Let's assemble the crew and see who's on the team for this mission. First up, the mastermind, the ManagerAgent. Like we said, this is the PI, the head of the lab. It's the only agent that sees the whole board, the complete picture. It takes in all the results from the other agents, analyzes them, and makes those crucial calls on what happens next. It's the conductor of this entire scientific orchestra.
Next, we've got the scout at the group, the IdeationAgent. This agent's whole job is to be creative. It digs through academic papers on arXiv, scours the web, and is basically looking for holes, gaps in what we already know. Once it finds one, it cooks up a solid, structured research plan for the team to tackle.
So, once that plan is ready, the ManagerAgent calls in the engineer. This is the ExperimentationAgent. It's the one that gets its hands dirty, digitally speaking. It takes the idea, translates it into working code, runs the actual experiments, and then, super important, saves every single thing, the code, the logs, the charts, right back into that shared workspace for everyone else.
Okay, this next agent might sound a little boring, but trust me, it's an absolute hero. It's the resource preparation agent. Think about it.
automated experiments can create a total mess, hundreds of files all over the place. This agent is like the team's librarian. It goes through all that chaos, cleans it up, organizes everything into a nice, neat folder, and even starts building out the bibliography. Without this step, the writer would be completely lost.
And with everything perfectly organized, it's time for the scribe to step in. This is the write-up agent, and it's an expert academic writer. It takes all those beautiful, organized materials and weaves them into a full publication-ready paper using proper academic tools like LaTeX. And get this, it has its own quality control. It literally cannot say, "I'm done," until the final PDF passes a whole checklist of requirements.
Last but not least, we have the critic, the reviewer agent. This agent's job is to be tough. It's the internal quality check. It acts just like a human peer reviewer, giving the finished paper a score out of 10 and providing really critical feedback. And that feedback goes straight to the manager agent, who uses it to make the final call. Is this paper good to go, or do we need to do another round of work?
All right, so we've met the whole team, the manager, the scout, the engineer, the whole crew. So let's see how they actually do on a real mission. We're talking from a blank slate all the way to a finished scientific paper. Let's watch this autonomous team in action.
So the paper walks through this amazing test run. And the key thing you have to remember is that these stages weren't programmed in advance. They emerged organically from the agent's decisions. Things start off great, but then, just like in the real world, they hit a snag. They have to recover. They get a tough review. And they have to go back and revise everything. It's a perfect mirror of how actual research works.
And bam, here's the roadblock. The write-up agent hits a wall. Task failed. It can't find the data it needs because of a simple broken file path. Now, this is exactly where a rigid, old-school system would have just completely crashed and given up. But here, the agent tries to fix it, can't, and then intelligently reports the problem back up the chain to the manager. It's handling a real-world, boring problem that would stop a dumber system in its tracks.
Okay, so the team recovers from that error and they actually produce a full first draft of the paper. But then, the reviewer agent comes in with a score, a 5 out of 10. Ouch, that's borderline at best. The feedback is basically, this is too simple, the analysis is weak. So now the manager agent has a huge decision to make. Do we publish this mediocre paper or do we go back to the drawing board? And it chose to iterate. The manager agent, all on its own, decided that a 5 out of 10 just wasn't good enough. So it sent the team back to work, run more experiments, use more data, and rewrite the whole thing. After that entire revision loop, the reviewer agent came back with a new score, a 7 out of 10, a solid accept. This is amazing. It shows the system can actually improve its own work based on its own critical feedback.
So let's step back for a second. What does all of this mean for the big picture? What does this tell us about the future of having AIs as our co-scientists?
I think this quote from the paper's conclusion just hits the nail on the head. They say this, it's not just a single system but a new framework for building bespoke co-scientists. The key takeaway isn't just this one team of agents, it's the underlying framework. It's like a Lego set that lets any scientist in any field build their own custom AI research assistant, perfectly tailored for whatever problem they're trying to solve. Really, the big shift here is in how we think about AI. We're moving away from AI as just a tool for automation and toward AI as a genuine creative partner in discovery. This framework is one of the first real blueprints for what that partnership could look like. Which leaves us with a pretty mind-blowing question to think about. If you could build your own personal AI research team, what would you ask it to discover?